All right, so the table below lists the distances in miles and cheapest airline fares in dollars to certain destinations for passengers flying out of Baltimore, Maryland as of January 8th, 1995. So it's saying they flew from Maryland and then to each of these places listed. Just to save making a really big chart, notice we just made 2 different columns there, but what would the explanatory variable be and what would the response variable be in this case?
Distance is the independent and fare is
Yep. So, explanatory or independent. Airfare is the response or dependent. So distance is going to be your L1, airfare is going to be your L2, and make sure you get both columns in there as well. And once you have all that in, you're going to want to do the Linear Reg and get the equation of the line. So yeah, I was actually just thinking about that. I think we'll probably do a short quiz on chapter 8 on Friday. Or depending on where we end up, we could do it on Thursday if y'all have a lot of stuff on Friday. But just kind of a short little quiz, or we could even do like a graded class assignment. I mean, not that it really makes a difference what we call it, but it would just be the difference of if I let you use your books and notes or not, basically. So, because the last quiz I gave on chapter 7, last year I actually gave a quiz on chapter 7 and 8. So, yeah. So I did one just on chapter 7. Because one year I did it just on chapter 7, I think probably because of where we were in the quarter. So I could do one just on 8, or I could do a modified 7 and 8 quiz to do a review of 7, since that was kind of a while ago as well. So we can see where we get kind of tomorrow and decide where we're at. I don't remember if I gave y'all your quizzes back or not, but I definitely have them graded. Okay. All right, so did we get a equation of the line?
I think so.
I'm confused on how to put it in. So like, when you put in the L1, L2, you put in both L1s at the same time?
Yeah. It's all going into the one. I just wrote it separate so it doesn't take up so much of the paper.
You do Linear Reg, right?
Yeah.
Okay, so 83.3. Yeah, and then 0.12.
Okay. So we want it written in this form, but we want to put in the actual words that go with it. So our Y is the response, which is going to be airfare. So we would say airfare with the little hat on it equals 83.3 plus 0.12 times x. Well, x is the explanatory variable, which is distance. Times distance. So that would officially be how we want to write that. Because what that does is when you go to plug in something else, let's say we wanted to know about, well, like jumping down to part C for just a second. It wants to know about San Francisco. Well, we know we can put in the distance, and we know that when we put that in, it's going to give us airfare. So we know exactly what's being plugged in because of the words that we're putting there. But, what airfare does the least squares regression line predict for a destination which is 900 miles away? So, what we're going to do there, do what?
You plug in 900 for distance.
Yep, we're just going to plug in 900 and then solve it. And remember, we're dealing with money, so we'll want 2 decimal places when we do that. So we'll have airfare hat is equal to 83.3 plus 0.12 times 900. Well, I'll write it in a second. There's something that I think we may have not put in the notes, but we're going to need, but I can add it into the next question. So, what airfare would the regression line predict for a flight to San Francisco, which is 2,842 miles from Baltimore? And then would you take this prediction as seriously as the one for 900 miles, and explain? So, we're going to find out what the airfare is for San Francisco, so we're going to plug that distance in. And there's going to be a decent amount to be written in this box, just FYI for spacing.
Or 424.4.
So $424.34. So when we look at that, we want to know, would we take this prediction as seriously as the one for 900 miles? So without me telling you anything, what do you think?
Yes. Well, yes, I guess.
Why?
Because it's more miles.
Okay. Ethan, what do you think? Yes, no?
I have literally no idea.
You want to agree with her, or do you want to be different? You're saying yes? Okay. So, no, and this is the part of where I don't think we talked about this in the notes, and I mean to add it every year, and I always forget, but no, okay,
Sorry, Ethan, I led you astray.
this is extrapolation.
Definitely was not in the notes.
So, extrapolation, this means that I'm going to pause here for a second. The value is outside the data set. So we had no other values that large, so we cannot just assume that
Okay, that makes sense.
it would have worked. So to finish the question, 2,842 is outside the data set. And
I
so
just looked at the chart.
be cautious when you're doing when you're looking, because we don't know what's going to happen. we can't guarantee that that would have been the case, and thus our model could be wrong because we don't have anything that's, I mean, even half as much as that. Well, I guess Dallas is Denver. Yeah. We have stuff that's about half of it, but we don't have something that's that, that much to compare it to, so.
That makes sense.
So then just one other one. Okay, so extrapolation is the values outside the data set. The other one is interpolation, which I'm just putting up here just so you have it since I failed to put it in the notes yet again. But this is that the value is included in the data set. So, like, 900 would be interpolation because it is inside. Like, we have numbers all around 900. So that one would be more realistic, more reliable, more serious, I guess. What is the slope of the regression model for predicting airfare from the distance? Explain what this slope means in context. So I'm looking for every additional something increases or decreases by something.
Okay, so as the distance increases, the airfare increases.
Okay, yeah, and we would want to be kind of specific about it. So something like, now, the way that it's written, we'll write it, well, I'll show you two different ways that you could write it. One would be how if you just took it very literally for what's written there, you would write. The other one would be if you want to make a little bit more logical sense, what you would put. So for each additional one mile of distance, airfare increases by 12 cents. And if we wanted to look at it a little bit more logically or to actually help us to understand a little bit better, we could also say, and either one would be fine, for every additional 100 miles of distance, airfare increases by $12. So if you would happen to give me either one of those, they would both be sufficient to answer the question. All right, so residuals. What's the formula for a residual?
Y minus Y with a hat.
Y minus Y hat. And that represents in words what? What is Y hat? Predicted, so what is just Y? Yeah, the actual value. Actual minus predicted. Okay, so then moving on to the next page. The actual airfare from Baltimore to Atlanta is $178. What is the residual value for Atlanta? What does this mean in context?
So it would be 178 minus 100.
So, where is it? So, 178 was what it actually was. But according to our, what am I looking for? Formula that we wrote, the airfare hat equals blah, blah, blah. We want to see what it would be predicted to be based off of that formula. And then we're going to subtract. So,
178 equals 83.3 plus 12x.
So it's going to be 0.12 times 576 because we know the distance. We're trying to figure out what the cost is going to be or what we think, what the predicted cost should be. The table tells us what it was. And from that, when you did your scatter plot, the Lin Reg gave you the line of what fit the data. So we know what it actually costs. We want to figure out what should it cost based on our prediction. So then we want actual minus predicted for our residual. So we would have 178 minus 152.42. So how much money is it off by? $25.58. So is our predicted too high or too low?
Too low.
So predicted airfare was too low. The residual for Chicago is minus 61.10. So I guess it's $61.10. What was the actual airfare for Chicago? What does that mean for the residual to be negative?
The actual is 94.
Did it? Oh. Well, okay, it is. I was looking at, I did what it was predicted to be and then did the residual and found what it should have been versus what it actually is in the chart. So yes, it should be 94 because it's in the chart. If it didn't give it to you, what you would have needed to do was find the predicted and then set it up as negative 61.10 is equal to the actual minus whatever that value was, which the value that I found was 156.74, which ended up giving you like $95, so it was about $1 off from what it said. But you would need to do that if it didn't give you, not if it wasn't in the chart. Solve if not in chart. And what does a negative residual mean? Or what would it tell us in regards to the actual versus the predicted?
Sorry, I'm sorry.
What does a negative residual tell us in terms of actual and predicted?
It's the predicted is higher than the actual.
Yes. Predicted is higher actual. All right, and then what is the correlation coefficient for the regression model for predicting airfare based on distance? So that's the R value from your calculator. You may have to go back to Linear to get it.
Just R
Yeah.
is 0.79.
So the variable of the correlation coefficient written R squared measures the proportion of variability in the Y variable that is explained by the regression model with the X variable. This percentage measures how closely the points fall to the least squares regression line and also provides an indication of how confident we can be of the predictions made with the line. So what proportion of variability in airfares is explained by the regression model with distance? So what we would need to do is find R squared. So you literally just square the 0.79. And just 2 decimal places is fine for that, if it gives you more than that.
I'm pretty sure my calculator already get. Gosh dang
It may have already given it to you. If the stat diagnostic is on, it'll give it to you.
0.63.
Okay. So what proportion of the variability in airfares is explained by the regression model with distance? We would say that about 63% of the variability in the airfare can be explained by the regression model with the distance. So then, for this residual plots thing, this comes up a little bit more in the next chapter, I think. But just to kind of give you a quick little interest thing, it's going to look something like this. We've got y minus y hat, and we've got x. And then basically, you just have a bunch of dots scattered around the line. And so kind of like, we kind of already talked about it a little bit in the notes in this section, but I think it comes up more next chapter. But if the plot of residuals versus the explanatory variable shows no pattern, a linear regression model is appropriate. There's only 3 total.
Oh my gosh, it goes all the way to L.
Yeah, this one's a little bit crazy. It's just long, because like your paper doesn't have the scatter plots drawn on them for you at the top, does it?
No.
Yeah, we're gonna have to draw them. I need to figure out now that I use the iPad how to like screenshot and like clip down the graphs and like input them into the thing. All right, so I don't know for sure if I assigned this particular problem about the baseball teams, but if from chapter 7, but if not, it is what it is. We're just gonna act like I did. So in chapter 7, we looked at the relationship between the number of wins by AL baseball teams and the average attendance at these home games for the 2006 season. Here are the scatter plot, the residual plot, and part of the regression analysis. And so we're going to draw all this stuff in. You're pretty much going to need this entire space. There's going to be 2 graphs and then some stuff written off to the side over here. So, let's see. So this first one is going to be just your general scatter plot, and then this one's going to be your residual plot. So we've got home attendance.
So that's how it's in
It's supposed to be home. It's hold on. I need to fix it. It's just I need to write with the skinnier pen. Okay. So home attendance on that side. The tick marks, there's going to be 5 of them. We have 22,500, 30,000. Here, I'm gonna do this so that we can see it, and then I'll move it over. It's gonna be a little blurry just because it's big. It's blurry on my screen. 37,500, 45,000, and 52,500. And then at the bottom, we're going to have, starting at 60, 70, 80, 90, and out to 100. And this is going to represent wins. So then I'm going to put all the dots on in red, and then we're going to add some other stuff to it. So and these just are like ballpark, like roughly. That line is supposed to represent the least squares regression line. that you would get from the data. And then the reason I made this 1 point so much bigger, this is representing something specific. This is going to be representing the Yankees. And we're going to be looking at the distance from there to the line, which would be, it's going to be given to you that is 52,500 minus 37,500, which is 15,000. That's like ballpark where it's supposed to be hitting. And just know that it may not exactly look like it on my graph, but that's what it's supposed to be. It's not perfect by any means. All right, do y'all have everything on that one? Okay. Once we have this drawn, this stuff that we have to do for the rest of this should go pretty quick. So, we may not get to it all till tomorrow, but okay. And then this is going to be the residual plot. So this is going to be residual in thousands. And then down here is just going to be the predicted values. So we're going to have -7, -2, 3, 8, 13, and 18. And there's going to be the line that's like for the residual or whatever is going through here. It's supposed to be about at 0, give or take. It doesn't look perfect, but there it is. So then the dots are going to be around that we had, so just for where they would fall. And again, all this is given to you. Oh, I need to put these, never mind, back up. This is 23,500, 28,500, 33,500, and 38,500 is what's going on here.
So it's going by,
Do what?
is it going by like?
It's going by 5,000 at the bottom. So it starts with 23,500 and then increases by 5,000 every time. Sorry, I know it's like super blurry on my screen too. Again, this really big point is going to be the Yankees. And so then the last little bit of information that it gives you is that the residual is 13,000. The dependent is home attendance. Okay, because as the number of wins changes, the amount of home attendance changes is what it's saying. The R-squared value is 48.5%. And then there's this little variable and the coefficient thing that's going to be here. So the constant is minus 14,364.5, and the winds 538.915. So this is your slope and y-intercept, and all of that would have been given to you. All right, so, we're going to just get through a couple of these probably because the bell's about to ring. But do you think a linear model is appropriate here? Okay. Yes, so although it's not strong, it is linear. So the model is appropriate. Okay, the conditions are met. We have quantitative variables that we're working with. We're talking about number of winds and the home attendance. Those are both quantitative. The scatter plot is linear. We've circled outliers potentially. Okay, they were given to us, but the Yankees are going to most likely be an outlier. We've at least accounted for the potential. And then the residual plot, there's no pattern to it. It's just scattered. So that's what we're looking for. We'll do B and then we'll stop. So interpreting the meaning of R squared in this context. So what this means, R squared's over here. So this is talking about variability. Okay, so we would say that about 48.5% of the variability in home attendance because we're told the home attendance is what is changing, can be explained by the regression model with the number of wins in the 2006 season. Okay, and that would be X. Home attendance is Y. I should put that in there. So we'll pick that up and finish it tomorrow. We should finish all the examples tomorrow because the stuff that's left is pretty quick just based on what we have given to us. We'll go from there. Definitely a quiz on Friday. Just don't know for sure what it'll be on yet. So.